So after looking at linear equation and their graphical representation, we can have a look at more complicated quadratic inequalities. Quadratic inequalities, just like quadratic equation, is any inequalities that contain a quadratic term. For example, x squared greater than minus x minus 5. Same as with the quadratic equations, we want to move everything on a one side, and we can just subtract minus x minus 5 from both sides, and it will give us x squared plus 4x and plus 5 greater than 0. In order to find the solution set of quadratic inequalities, we first need to find roots of this quadratic term. So in order to find the roots, you remember, we can solve an equation. We can write it down: x squared plus 4x plus 5 equals to 0. Since this equation is in a normal form, we can use PQ formula. So let's find the discriminant first. It's p divided to 2 squared minus q, which is equal to 2 squared minus 5, which gives us minus 1, and it's smaller than 0. So discriminant is negative, which means this quadratic term has no roots. As you remember from the previous chapter, quadratic equation can have no roots, one or two roots. We will have a look at all three of these examples, and we'll start with example when we have no roots, like here. So one way to find the solution set for this inequality is to complete the square. If you remember, I will write it down here. We had the completing square formula, which is x squared plus p x plus q, and we just rewrite it as x plus p divided to 2 squared plus q minus p divided to 2 squared. So this was our formula. So we can rewrite this into the square. So we will do the following. So we will follow our formula here, and we will have x plus p is 4 here, 4 divided by 2, and we have square here, plus q, which is 5, minus 4 divided by 2 squared. So this all give us x plus 2 squared. And if you look here, here we will get 2 squared, which is 4 from this. And 5 minus 4 will be equal to 1. So we completed the square. Let's rewrite it again. X plus 2 squared plus 1 is greater than 0. Since squares are always greater than or equal to 0, if we put any number instead of x, it will always satisfy the inequality. For example, this will be always bigger than 0, and we add 1, it will be positive. So it means that any real number that we can take will fulfill it. So that's why solution set for this inequality will be all real numbers that we have. For equations, it's much easier. You just look for roots. If there is no roots, the solution set is empty. Okay, we're done. For an inequality, it's a little bit more complicated. You have to work a little more to find a solution set, and you can't just leave it like that and say there's no roots. And one way is completing the square that we had before. There are many ways to do that, and I'm just showing you one way. If we look at the reversed inequality, so I will just rewrite here that we had, and we rewrote this by using completing square method. Square plus 1 greater than 0. Yeah. So, and our solution set was this one. Here, if we also rewrite it like this, but we will just have a reverse sign. And again, by completing the square, we will get the same term here, but the sign will be opposite. How to deal with this one? So, for example, we will get any number here, would be negative, would be positive, any real number that we will get here, for example, minus 1. Minus 1 plus 2 or minus 100. We will always end up getting something which is greater or equal to 0. And fulfilling our inequality, because we need something which is smaller than 0. So this inequality doesn't follow the logic, and that's why the solution set of this inequality is empty set. That's why you have to be very, very careful and critical looking at the inequality sign, because we had here two almost identical examples but with completely different solution set. So this was example with no roots. And the next example is where we have one root. So similarly as in the previous example, we will move all elements to the left side and solve the quadratic term. So here we have x squared minus 4x plus 4 greater than 0. So then we will take this term, x squared minus 4x plus 4, and try to find its roots. And if we find the discriminant with the formula p divided to 2 squared minus q, so it's minus 2 squared minus 4, which is equals to 0. So there will be only one root. X will be equal to, as you remember, minus b divided by 2, which is 2. Next, we'll look at the coefficients of our quadratic term here. Coefficient of x squared is 1, which is positive, and hence for all x values that we will always end up something positive. But since we have one root, we can't include this point into our solution set. Thus, our solution set will include all real numbers except 2. If we look at this equation, so if we will have negative numbers, they always will be positive by squaring it, and here in this term, negative numbers will become positive number because of minus 4 here. So if you look at this equation closely, if we put any number here except for the 2, it will always be positive, and our inequality will always fulfill except for the 2. And since we have this sign here, we cannot include it in our solution set. So we write it like this, or also you can write it like this. So if we look to the similar example like this here, but with a different sign. So we take x squared minus 4x plus 4 greater or equal to 0. So this inequality has different sign here. In this case, we have also one root 2, but because we have greater or equal to, then we can include it in our solution set. Thus, the solution set will be all real numbers. Next one is also same quadratic term, x squared minus 4x plus 4, but this time is less or equal to 0. This is very interesting. So this one can be only fulfilled when x is equal to 2. Then it will be equal to 0, right, when we have one root. So for this particular inequality, our solution set will only include 2, because all the other numbers will automatically give us something that is larger than 0. That's why our solution set will be something that equals to 0. And finally, if we will have the quadratic term less but without equal sign, then the solution set will be empty, because no real number can fulfill this inequality. So that's why, one more time, I'm telling it's very important to look at inequality sign. Yes, it's important to solve the quadratic term, and then you have to look at the sign. So this was an example with one quadratic term, but different signs, and all of them have different inequality signs, and all of them have completely different solution sets. And finally, let's consider the situation when discriminant of quadratic term is greater than 0 and we have two roots. So let's take a simple term, x squared greater than 2x. So same as previously, we move everything to the one side and then we look at this quadratic term and try to find roots. So again, we try to find discriminant, which is p divided by 2 squared minus q. This will give us minus 1 squared. And since we don't have any q here, minus 0, which equals to 1. So x1 will be minus p divided by 2 plus square root of discriminant, which is 1 plus 1 and 2. And x2 will be minus p divided by 2 minus square root of discriminant, which will be 0. So we have two roots here, 2 and 0. The next thing, we have to look at the coefficient before our quadratic term. Coefficient of x squared is again 1 and it's positive. So let's imagine the number line and we have two roots here, which is 0 and 2. And we have something here, here, and here. We look at numbers here. So any numbers that are smaller than 0, they are fulfilling our inequality. Because if we put any negative number here, we will always get something bigger than 0. Great. And then we can take a number somewhere between here, which is 1, and have a look at our inequality. And we can see that inequality cannot be fulfilled in this interval. Next, we'll look at something greater than 2. And obviously, any number that will be greater than 2 will give us positive number. And any number here will also fulfill our inequality. Therefore, the solution set for this inequality will include all the real numbers except 0, 2, and everything that lies between 0 and 2. I know it's complicated, but please stay with me. So let's have a look again in the same quadratic term, but with a different sign here. So we can just make it more clear. Also remove our discriminant from here. We have a number line and we have two roots, 0 and 2. And we have to look carefully on this. So any number smaller than 0 cannot fulfill our inequality. And again, any number that is larger than 2 cannot fulfill our inequality because we will always have a positive things. But if we take again 1, which lies just in between, we get something smaller than 0. We will get minus 1. So it means that everything in the interval between 0 and 2 will be our solution set. Except these 2 points will be empty because we don't have the equality sign here. Yeah, and let's have a look at the third example. Now we have this nice sign. X squared minus 2x is less than or equal to 0. Again, we will draw the intervals, but because now we are allowed to be equal to 0, we include them to the solution set. Again, we check, can we fulfill this inequality by any number smaller than 0? Minus 1, for example. We can't get anything smaller than 0. Same goes everything bigger than 2. But again, any number between those two will be included in our solution set, including 0 and 2, because we have this less than or equal to sign. Yeah, again, you have to be very careful with the inequality signs.